Alright, homework 1.4. I'll be going over problems 1, 5, 7, 11, 15, 17, 21, 23, 25, and 27. Oh, also, you can contact me on Discord if you need help, or Sohoma Yash, or whoever, whatever, it doesn't matter, if you need any help, because I'm going to be going over these kind of fast. So for number 1, it's asking, which of the following schematic drawings best describes solution of lithium sulfate? So lithium sulfate is an ionic compound. And ionic compounds generally, not always, but in this situation, will deionize into like ions. And we will see that it will deionize into 2 lithium ions and 1 sulfate ion, because there are 2 lithiums and 1 sulfate. So that's why A and B are wrong, because that's not what's happening. We don't see a 2-to-1 ratio positive negative charges, which is happening in C. C has 2 positive charges for every 1 negative charge, which corresponds to the formula. So for number 5, this is just saying that we don't know the identity of a compound, but if we put it in water, we know that it doesn't precipitate, or it dissolves just fine. And we know that if we put sodium sulfate in it, a precipitate forms. So with that information, and I guess for now you can use a solubility chart, you should be able to solve this problem. So immediately using a chart and my brain, I know that lead chloride won't work here, because lead chloride, generally lead does not want to be soluble at all, except for nitrates. Nitrates is like, I think, the only exception. I think there might be like 1 or 2 more, but generally lead never dissolves. So I'm just going to cross that out. Now we're left with barium chloride and zinc chloride, and we have to see if either one of those substances forms a precipitate with sodium sulfate. Now, using our little solubility chart, we know that barium sulfate forms a precipitate. So we know that barium chloride is the solution, because first of all, it dissolves in water just fine, and second of all, it forms a precipitate with sodium sulfate. So we know that the answer is BaCl. Alright, cool. Next problem. Alright, number 7. So this question is basically just asking you what never forms precipitates, because a spectator ion is just something that never forms precipitate in a reaction. It's just something that just stays in solution, chills out, doesn't do anything. So let's find out what those are. So using your solubility chart or just your memory, you would find that chlorine, sulfur, and sulfate are not correct here, because chlorine occasionally forms precipitates, which isn't always, and same with sulfur, same with sulfate. So I'm crossing them out. But nitrates and ammonias never, ever, 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 ever form precipitates, so good thing to memorize. So yeah, answers are B and C. Now, number 11. So this is just saying someone thought that something that is able to conduct electricity is due to the movement of electrons through the solution. Now that's wrong, because electrons conduct electricity because the dissolved ions carry charge through the solution. So it's not that it's moving around, it's that the ions can carry their charge, because you know how there are ions in your solution. Like if you break up NaCl, you're going to have Na plus and Cl minus charges. It's not that they can move around. I mean, not necessarily. It's just that there's ions. There's things that hold electricity in them that are free. So that carries an electric charge, which can conduct electricity because it moves through just fine. But if you just have NaCl, electricity is going to hit it and nothing's going to happen. But if you put a electric bolt through this, it's going to come out just fine. So yeah, that's 7 and 11. Okay, so 15 and 17 are kind of simple questions, so I'm not going to go into as depth with them, but I'll explain them pretty briefly. So 15 is just asking what ions are present when you dissolve them. So you just split these up into ions. So for example, I'll just write the one for ZnCl. For zinc chloride, you have ZnCl 2, and then when that breaks up, you just get Zn 2 plus 2 Cl minus, and that's the same thing for all of these. HNO3, you get H plus and NO3 minus. For NH4 2 SO4, again same thing. Same for D, easy, simple. Just what can you break this into? Now for 17. Formic acid is weak electrolyte. What solute particles are present in an aqueous solution of this compound? So it's just asking, if you were to split up HCOOH into its 2 ions, what would you get? Because it's saying what solute particles. So if you broke it up, what would you get? So this might be a little more difficult. HCOOH is a acid, and you're gonna see like this kind of shape, this weird shape, like I don't know, like there's a compound that's like this. Actually, I think it's HC or whatever. Like you'll see compounds with this odd shape a lot in chemistry, but all it is that you just break this up into the body and then the H. And that's what you get. And also, sorry, you want to do a double, like a double arrow because the ions can recombine into the acid just normally. So you put both ways because both the reactions are happening at the same time. You'll be getting more into this in acid base, but that's important to know because you might be quizzed on that. Because I don't know why else she would give this as homework. So yeah, major takeaways from this problem. The weird shape is just the I guess the body of the chemical, and then the H separate. So like the body and then the H. That's basically it. And then you for equations involving acids and bases, you usually want to do this instead of just this because they can recombine. All right, next problem. Okay, so for problems 21 and 23, I'm only going to be going over part C because these are kind of tedious and they're just trying to give you practice. But if you need any help, just go ahead. You can always ask me. So, but I'm only going to go for part C for both of these problems. So for 21, it's basically asking, when you mix these solutions, will there be precipitate? And if so, make the balancing chemical equation. So as I said before, lead, with the exception of nitrate and ammonium, will always, hopefully, like basically always, not be soluble. Do not trust lead with being soluble unless it's with nitrate or ammonium. That's something important to know. So we have, so basically, lead and sulfate will be the precipitate. Sorry, I forgot to clarify that. Anyway, so in order to make the chemical equation, let's just get our molecules together. Plus PbNO3, PbSO4, plus FeNO3. And that's your answer. And this is the precipitate. All right, next problem. Name the spectator ions in any reaction that may be involved when each of the following pairs of solutions are mixed. So for part C, we know that the things that will not be spectator ions, the things that will form a reaction, will be calcium and phosphate, because phosphate, again, is one of those things that I don't usually see becoming soluble. So that's the first thing I look for. So phosphate and calcium too doesn't really like to be soluble. So I'm going to cross out phosphorus and calcium, and I'm going to say that my spectator ions are Cl and NH4. Now, I know this might be a little weird because I am saying all of these things like you should have memorized them, but don't worry, you don't need to. Just try to keep in mind these trends, and for now, you can always look at the solubility chart and just work from there. All right, next problem. All right, so for 25, this is kind of a weird problem. Separate samples of a solution of unknown salt are treated with dilute solutions of hydrobromic acid, sulfuric acid, and sodium hydroxide. A precipitate forms in all three cases. Which of the following cations could it be? I think that was potassium and lead and barium. So this problem is basically just asking you, can lead and barium and potassium form precipitate with all three ions, bromine, sulfate, and hydroxide? So you'll be using your solubility chart for this problem. So first off with potassium potassium does not form a precipitate bond with any of these, meaning that if you look at your solubility chart, potassium is soluble with all of these compounds. It does not form anything with bromine, does not form anything with sulfate, and does not form anything with hydroxide. And with barium only forms a precipitate with sulfate, not with bromine and not with hydroxide, so we're also crossing that out. And then with lead, which I've said so many times before, lead does not want to dissolve. It does not want to be soluble. So again, lead is going to be insoluble in this reaction, or in this example. So lead is the answer. And again, use your solubility chart for these. No one's expecting to memorize these. It's just like, use it, don't worry about it. Okay, don't worry about memorizing. That's not the focus. It's learning the trends and learning the overall like themes and general topics that like the general trends, okay? So, 25, answer is lead. So now for 27, you know that unlabeled bottle contains a solution of one of the following: silver nitrate, calcium chloride, or aluminum sulfate. A friend suggests that you test a portion of the solution with barium nitrate and then with sodium chloride. Explain how these two tests together would be sufficient. So the question is asking to explain how barium nitrate and sodium chloride together, how those ions interact with our potential solution, like our potential ions like silver, calcium, aluminum, how those interact to form precipitates, and using that information, how can we specify or how can we remove or how can we isolate these ions? So using this handy dandy table that I got, okay, using barium nitrate, we can find that there will be a participate. Is that the word? Yeah, precipitate. Sorry, there will be a precipitate with only barium nitrate and aluminum sulfide. So we can cross out this, and then with sodium chloride, the only thing that will form a precipitate in this reaction, and will not be isolated by barium nitrate, will be calcium chloride, because silver nitrate and sodium chloride form a precipitate. So in this case, this is enough to isolate because they all point to different things. Now again, you would use your solubility chart for this, and I would not know how to do it any other way. But yeah, it's important to use that logic of being able to isolate, because this will be on the test for sure. Being able to isolate like what it is through like your general knowledge or through a solubility chart to find what the identity of an ion is. So that's an important skill to use, and if you still like are struggling with that, I would recommend doing more practice problems or getting a Khan Academy video for that. So yeah, that's all. Thanks. Have a good night.